Let's apply what we have done to another kind of functions and polynomial functions, namely the exponential function. So say we have this function f of t, which is 2t e of minus 0.5t, and we want to see if it has a minimum, a maximum, or an inflection point. Okay, so to do that, we first need to calculate the derivative. Well, we are going to use the product rule, so u of t is t, so u prime of t would be 1, and v of t would be e of minus 0.5t, so therefore v prime of t would be minus 0.5 e minus 0.5t. So, okay, so that means that the derivative would be u prime v, so it's e minus 0.5t plus v prime u minus t times 0.5 e minus 0.5t. Okay, so we can factorize a bit by e minus 0.5t, which is 1 minus 0.5t, which actually we can simplify a bit, e minus 0.5t times 2 minus t. So f prime of t is equal to 0 when, well, this is always different of 0, and when t equal to. What is the value at that point? Well, f of 2 is equal to 2 times 2 times e minus 0.5 times 2, which is 4 e minus 1, which is 4 over e. So therefore, there is an extremum at the point 2, 4 over e. Now, okay, coming back on f prime of t is e minus 0.5t 2 minus t. This is always positive. So therefore, f prime of t is negative when t is, greater than 2. And positive when t is less than 2. Okay, so it changes sign at t equal 2, so therefore it's a maximum. So maximum, which is 2 for the e. Let's keep going. The limit when t tends towards minus infinity of f of t, which is the limit when t tends towards minus infinity of 2t e minus 0.5t, well, this tends towards, well, minus 0.5t, because t tends towards minus infinity, is going to tend towards plus infinity, so therefore there's going to be plus infinity, and then times something which is minus infinity, so it's going to be minus infinity. And for the limit when t tends towards plus infinity of f of t is the limit when t tends towards plus infinity of 2t e minus 0.5t. So the minus 0.5t is going to tend towards minus infinity, which means that it's going to tend towards 0. And then there is t tending towards plus infinity, but e power of something tends towards, grows much faster than t, so therefore it's going to be 0. Okay, now let's look at the second derivative. So we knew that f prime was equal to e minus t 2 minus t, e minus 0.5t 2 minus t. So if we were going to redifferentiate that again, so we would again use the product rule. So u of t would be e minus 0.5 t, so therefore u prime of t would be minus 0.5 e minus 0.5 t, and then v of t would be 2 minus t, so therefore v prime would be minus 1. So therefore the second derivative would be u prime v, so that's minus 0.5 e minus 0.5 t times 2 minus t, minus v prime u plus e minus 0.5 t, which we can factorize by e minus 0.5 t. So that's what? Minus 1 plus 0.5 t plus 1. Yes. So, okay. So, u prime v minus v prime u. Oh, no. Up. I made a mistake here. Minus. So therefore, okay. Minus 1, and it's minus 1. So therefore, f2 prime is equal to e minus 0.5 t, which is always different of 0. And here we have 0.5 t minus 2. Yep. So therefore, f2 prime of t equals 0 when t equal 4. So therefore we have an inflection point at t equals 4, and f of 4 is what? F of 4 is equal to 2 times 4e minus 0.5 times 4, which is equal to 8 e of minus 2, so therefore it's 8 over e squared. So 8 over e squared. Okay, so what does it look like? Actually, I shouldn't do that now. Y, x. So what are the values? At x equals 0, e goes for 0. And then we have a point here at xt equal 2, which the maximum was at 4 over e. 4 over e, 4 divided by e is approximately 1.5. Let's just change a bit approximately, so it's 4 over e. Right, so it's around here. And here there is a tangent which is horizontal. And then we have an inflection point at 4, and what was the value? 8 over e squared. 8 divided by e squared, which is approximately 1. So it's around here. So here we have an inflection point, and we know also that it tends towards 0, so it looks like that. There you go. And this is the inflection point, where basically we could get the values of the slope here. But so from here, it's concave down. and from the inflection point it's concave up. That's what the graph looks like.